The modern industrial megafactory is a landscape of rigorous structural order. Every pipe, valve, and silo imposes exact physical specifications on a massive scale. But before that order can be established, there is chemistry. The process begins with heavy, viscous natural fats and raw golden oils. These slick, unstable liquids must be chemically altered before they can reach the target state, a hard, uniform, and hygienic solid. That conversion requires a highly caustic catalyst, sodium hydroxide, better known as lye. In this system, these volatile liquids are measured in exact ratios and continuously pumped into a heavy-duty reactor. When the fats, lye, and extreme heat collide, they trigger saponification, a heat-generating reaction that restructures the molecules of the fat into soap. This process strips away glycerin, a natural byproduct that the facility must either manage or extract from the churning mixture. What remains is soap, but it is currently a hot, volatile liquid carrying far too much water to hold a permanent shape. Initiating this chemical phase is only the start. Now, the factory's mechanical line begins to organize the fluid. To prevent the boiling liquid soap from settling into an uneven sludge, the excess water must be stripped away instantly. The pressurized liquid is blasted through atomizing nozzles into a vacuum chamber, hitting freezing steel walls. The sudden drop in pressure and rapid temperature shift cause the liquid to flash dry, crystallizing into delicate snowy flakes. These flakes cascade out of the chamber as dehydrated, standardized base soap noodles. Converting a boiling fluid into a predictable dry particulate allows the factory to safely handle and manipulate the material at an industrial scale. Looking at this workflow, these dry base noodles are first categorized and divided based on their intended product line. They are diverted into specific channels where specialized additives, pigments, and fragrance oils are injected into the mix. Heavy-duty Sigma mixers, driven by industrial motors, knead the dry particulate and liquid additives together. But standard mixing can leave behind microscopic air pockets and granular inconsistencies that would compromise the strength of a finished bar. The soap is fed through massive steel cylinders. The shearing forces of this three-roll mill crush the material into paper-thin sheets. This mechanical crushing converts a loose, dusty mixture into a smooth, unified paste. Inside this barrel, the refined paste undergoes extreme compression to form a solid capable of surviving global transport. Massive internal steel augers continuously grab and drive the material forward under high mechanical pressure. The paste hits a specifically shaped die and is forced outward, emerging as a dense, continuous log of solid soap. Applying vacuum pressure during this extrusion ensures maximum internal density. By removing trapped air, the factory ensures the finished bar will not crack or splinter in a consumer's hands. The continuous log meets a high-speed wire cutting mechanism that slices the moving soap into individual billets. Following the process line, the billets feed directly into an automated press. In a fraction of a second, heavy steel dies slam down, carving the final shape and embossing the brand logo. Every newly stamped bar immediately enters an automated gauntlet designed to verify its dimensions. Highly sensitive industrial scanners inspect the bars on the belt, ensuring the heavy milling equipment has not left behind any microscopic metal contamination. The geometric tolerance here is 0. If a bar's dimensions or density deviate by even a fraction, a pneumatic piston rejects it, preventing a single flawed unit from reaching the warehouse. The surviving bars are rushed directly into a horizontal flow wrapping machine. This wrapping unit pulls from continuous rolls of specialized film, using robotic folders to encase hundreds of units every minute. This packaging creates a sealed microclimate, locking in the exact moisture ratio and preserving volatile fragrance compounds. From here, thousands of identical units glide upward on belts, entering the logistical network of the global supply chain. By harnessing heat, vacuum, and pressure, the factory has organized raw chemical reactions into millions of uniform, shelf-stable bars.